Hello, we are discussing the exercises in the MOSFET amplifier configurations. Continuing from there, for RL equal to 10 kilo ohms, GV is equal to 10 kilo ohm by 200 plus 10 kilo ohm, that will give you 10 by 10.2, that is 0.98 volts per volt. Next, 5.32, refer to the figure 5.50b, show that the taking R0 into account results in AV0 is equal to R0 by R0 plus 1 by GM. Now, recalling that R0 is equal to VA by ID and GM is equal to 2ID by VOV, find AVO0 in terms of VA and VOV for a technology for which VA is equal to 20 volts. What is the maximum VOV at which the transistor can be operated while obtaining AV0 greater than 0.99 volts per watt? Now the circuit is shown over here, and this is replaced by the what we call T model over here, wherein we are considering the R0 also. Now, looking back on the network theory, then we can say that when we do the analysis, then the sources should be disconnected. This is a current source, voltage source should go to ground, or it should be shorted, and the current source should be open circuited. So if you open circuit this, then naturally you can see that between this point and the ground, you have RL. Between this point and again the ground, you have R0. That means between this point and the ground, you have RL as well as R0. RL and R0 will come in parallel with each other. Thus, we'll get the equivalent circuit, which is something like this, wherein we'll have here 1 by GM and RL and R0. Output will be between this point and the ground. Whereas the input side, if you see over here, is this, and the input is across between this point and the ground. That means this point and the ground over here, which is the combination of 1 by GM and the RL. Naturally, in parallel with RL, R0 will come because this is grounded and this is open. That's why we have this circuit. Now, having this circuit, you can see that these two are in parallel with each other. So therefore, the output voltage, whatever current is there, I here, same will current flow through the parallel combination of RL and R0. So VI will be equal to I into 1 plus GM multiplied by 1 plus GM plus of RL in parallel with R0. Whereas V0 will be I into the parallel combination of RL and R0. So the AV, which is considering RL also, is V0 by VI is equal to V0 is I into the parallel combination over here, and that is RL in parallel with R0, and the what we call VI will be I into the 1 by GM plus RL in parallel with R0, 1 by GM plus RL plus R0. So we will have here the equation AV is equal to RL in parallel with R0, II will cancel, 1 by GM plus RL in parallel with R0. Now AV0, which is AV at RL equal to infinity, will be when we take RL equal to infinity, infinite in parallel with R0 will be in R0 itself, and infinite with parallel with this R0 again will be R0 itself. So therefore, we are left with R0 divided by 1 plus GM plus R0, and you can try to write all that like GM R0 divided by 1 plus GM R0 also for this. Then AV0 will be equal to VA by ID. The value of R0 turns out to be VI by AD. I should have put mod over here, and here VA by ID. This is VOV by 2 ID, and that is VA by VA plus V0 by 2. So 20 by 20 plus V0 by 2, VA is 20, and here again 20 plus V0 by 2 is greater than 0.99. That will give us 20 greater than 19.8 plus 0.495 V0. If you just cross multiply this, then we'll have 0.495 V0 less than 20 minus 19.8. That is, this will become 0.2. So V0 will be less than 0.52 by divided by 0.495. So V0 will be less than approximately 0.4. So V0 maximum will be the maximum value of this will be 0.4. So thus we can find the solution. With this, we come to the end of this